In this video, we will go over using the Fiery Color Profiler to create ICC profiles in Digital Factory using a spectrophotometer. During this process, we will create ink limits, perform linearization, and generate the ICC profiles. Because every printer has unique features and capabilities, your print mode creation process may vary slightly from the workflow shown in this video. The same principle applies to the spectrophotometer you use. In this video, we will be using the Fiery ES3000. You may not see all the dialogues demonstrated in this video, but keep in mind that the overall print mode creation concept is consistent across all printers and spectrophotometers. To begin creating a print mode, ensure that the printer and spectrophotometer are installed and functioning according to their manufacturer's instructions. Once the devices are operational, click on the Devices menu and select Manage Print Modes. The Print Mode Manager dialog will open. Click on the Show Print Modes for drop-down list and select the Universal Control Driver Plus. The Cues Available option will show Universal Control Driver Plus. Lastly, you need to select the spectrophotometer that will be used. Click on the spectrophotometers drop-down list and select the Fiery ES3000. The process of scanning the calibration charts can be made easier if the patches creating the calibration charts are set to medium, which is one size up from the default size. Click on the three dots to the right of the name of spectrophotometer you have selected. The Instrument Settings dialog will open. Click on the Settings button to the right of the name of your spectrophotometer. Then click on the drop-down list for patch size and select Medium. With the patch size changed, click OK. Click Save to lock in the patch size. You are now ready to select a print mode. The print mode list is found in the lower half of the dialog. If your printer has the available print modes, start with a pre-made print mode for the type of shirt you are calibrating. If you are printing on a colored shirt, you would start by selecting a print mode for colored garments. If you are calibrating for a black shirt, select a print mode for black shirts. And finally, if you are calibrating for white shirts, select a print mode for white shirts. The target shirt for our calibration purposes will be black, so select the print mode named Print Mode 01. 720 by 1800 6P CMYKW black shirt. If there are no print modes specific to the shirt color, you can select any other print mode to get started. With the printer and spectrophotometer set and print mode selected, you are ready to begin the print mode creation process using the Fiery Color Profiler. The target shirt for our calibration purposes will be black, so select the print mode named Print Mode 1720 by 1800 6P CMYKW black shirt. If there are no print modes specific to the shirt color, you can select any other print mode to get started. With the printer set, spectrophotometer set, and print mode selected, you are ready to begin the creation process using the new Fiery Color Profiler. Click on the Fiery Color Profiler icon located at the top of the Print Mode Manager dialog. A dialog box will appear prompting you to rename the print mode. This name is based on the resolution, number of passes, inks available from the printer, and the target shirt color. We will add the word calibrated to the end of the name. Deselect Enable Advanced Screening. This will be covered in the Fiery Color Profiler Advanced Features Express video. This option allows for finer control over how digital image data is translated into physical ink dots, resulting in a more accurate and visually appealing final print, especially useful for applications such as screen printing film creation or direct-to-film printing. Now that the print mode is newly named, click OK to continue. If your printer includes a separate white ink channel, Digital Factory will detect this and ask if you would like to set the maximum white ink. Leave this option set to Yes, as it is important for achieving the best possible print results. You will also see an option to automatically send jobs to the printer. With this enabled, the charts and test pages generated during the Fiery Color Profiler process are sent directly to the printer using the media specs bypassing the queue. If this option is set to No, the charts or test pages will instead be sent to the queue in Digital Factory, allowing you to make adjustments such as resizing charts to fit your target media. For example, if a patch chart is too large to fit on a small shirt, it can be scaled to fit. For this exercise, both options are set to Yes. Click Next to proceed. You are now in the maximum white ink setup portion of the process. The first field contains the page size of the print bed. In this example, the page size is automatically set to A3, which is the setting for the queue that is printing the charts. Next, you can set the image used to evaluate the maximum white ink. A recommended image is provided which includes elements for better results to evaluate the white ink value. You also have the option to use a custom image if you feel you need to adjust your white for a specific purpose. For this example, we will leave the selection to the recommended image. This is automatically selected. The final option in this dialog allows you to set the image size that will be printed in the test chart. Adjusting the size will change the number of samples per page. Scaling the image down will increase the number of samples per page, and scaling the image up will decrease the number per page. Set the width to 3 inches. With this complete, click Next. In the following dialog, you can modify your printer options. These must be configured at this stage as they cannot be changed later. All future tests in the color profile creation process will use the printer settings you define here. You can typically leave these at their default values unless your printer manufacturer recommends specific settings. Click Next to continue. Depending on your printer, you may now see the ink droplet size setup dialog. The default settings are recommended. The advanced settings option will be covered in the Fiery Color Profiler Advanced Features Express video. Click Next. This next dialog helps set the maximum white ink for the white underbase. Here, you will set the minimum and maximum white ink levels for the samples and the incremental steps between the minimum and maximum white ink values. For this exercise, leave the minimum white ink at 50% and the maximum value at 100%. The increments are set to 10%. This will create 6 samples. When the ink chart settings are complete, click on Print Max White Ink Chart. Once printed, press the charts onto your target black shirt for review. Examine each sample to find the one that provides enough white ink for a solid, opaque base and vibrant colors without oversaturating or flooding the design. After reviewing the pressed samples, the best result in this example is achieved at 60% white ink coverage. In the field representing the preferred white ink percentage found at the bottom right, type 60. Click Next to continue. This takes you to the white under black dialog. This setting reduces the amount of white ink used under darker areas of the image based on the values that have been predetermined for the type of printer being used. Areas that do not need as much white to block the shirt color will not need as much white ink, leading to savings in ink usage and improve the feel of the final transfer. There are 3 options: direct-to-garment or direct-to-film printers, recommended for vibrant images and to help prevent cracking or fading. Second option, for UV printers, which adds an opaque base for UV printed designs and own choice for advanced users, which will be covered in the Fiery Color Profiler Advanced Features Express video. For this example, we are setting a print mode for DTF. Therefore, ensure the first option for DTF is selected. The recommended value of 50% white under black is automatically applied. With the DTF option selected, click Finish. The next dialog introduces the Fiery Color Profiler and reminds you to ensure that both the printer and spectrophotometer are turned on. Once confirmed, click Next to proceed. You are now in the calibration dialog. This will launch the calibrator. Double-check that the information shown, printer, queue, spectrophotometer, and media page size, matches your setup. The gear icon on the right provides access to advanced settings, which will be covered in the Fiery Color Profiler Advanced Features Express video. Once all information is confirmed, click Begin Calibration. Digital Factory will minimize automatically, and the Fiery Calibration dialog will open. Because Auto Print Mode was enabled earlier, you will not need to interact with Digital Factory during this process. The first dialog in Fiery Calibrator is where you will set the total ink limit. The top section provides information about the chart that will be printed. In this example, the chart contains 496 patches, arranged in 8 rows and 31 columns. The default total ink limit is 400%, allowing up to 100% of each cyan, magenta, yellow, and black ink. Click Print Visual Chart. A preview of the chart will appear, showing what will be printed based on your settings. Click Print. The chart will then be sent to Digital Factory to be ripped and printed on your printer. After printing onto your media, press the chart onto your target shirt for evaluation. The printed chart displays ink ramps, CMYK combinations, from 100% to 400% in increasing increments. Your goal is to determine the maximum usable ink limit for your garment. Each patch contains a hexagon in the center, which is always printed at 400% total ink. The patch where the hexagon becomes invisible or blends into the surrounding patch color indicates the correct total ink limit for your media. After reviewing the press chart on your garment, the hexagon blends at 200%. Enter 200 in the total ink limit field. In the advanced settings, you can leave the redundant patches for Smart Data Averaging option enabled. This creates multiple patches of certain colors to improve measurement accuracy. Although this is an advanced feature, it is recommended to keep it enabled for better results. After changing the total ink limit, click Next. The calibration chart will now be printed. Its appearance varies depending on your spectrophotometer. This is the chart created for the Fiery SE3000. After pressing the chart onto your garment, follow the instructions shown at the bottom of the dialog. These will differ based on the device you are using. For example, when using the Fiery SE3000 spectrophotometer, the instructions will guide you to place the device on its calibration cradle. Click Next. Proceed to scan the chart on the shirt using your spectrophotometer. The scanning process will differ depending on which spectrophotometer you are using. For the Fiery SE3000, the device has a rail that helps guide the scanner across the chart to be scanned. Scanning the chart one row at a time instead of one patch at a time greatly reduces the time needed to scan the entire chart into the Fiery Color Profiler. The dialog displays your scanning progress. Green check marks indicate successful scans for each row of patches. If any patch values cannot be read for any reason, an error message will appear at the bottom. You will have to attempt to scan that row again, and once successful, continue to complete scanning the remaining chart. Once all rows are scanned successfully, click Next. You will be shown the resulting calibration curves: cyan, magenta, yellow, and black. If your printer uses additional ink such as orange, red, green, or blue, their curves will also appear here. These curves are saved into the calibration settings of the print mode. After reviewing the results, click Next. You are now in the Create Profile dialog. Here, the measurements taken with your specific printer, media, and ink combination are used to generate a custom output profile. There are two profiling modes, Easy Mode and Advanced Mode. Since this video covers the basics, we will use Easy Mode. Advanced Mode will be covered in the Fiery Color Profiler Advanced Features Express video. Click Continue. You will now print the profiling charts. The profiling charts are automatically optimized for the spectrophotometer you are using. In this case, the chart takes up 2 pages. It also depends on the size of patch you set at the beginning. The larger the patch size, the more pages are needed to display all the patches in the chart. After the charts are printed, transfer them onto your shirts. This time, if possible, use white shirts. It is easier to see any banding or other anomalies better than on a black shirt. The white shirt won't affect the results of the spectrophotometer. This workflow is designed to minimize both the number and size of charts needed, streamlining the process with the consideration that every chart must be printed and transferred onto a garment for evaluation and scanning, which can become time-consuming. You will be prompted to prepare your spectrophotometer. For the Fiery SE3000, place the device in its calibration cradle. Click Next. With the first shirt ready for scanning, begin to scan the first part of the chart. The process is the same as the first scan, except the chart is split into 2 parts to fit onto the shirts. Therefore, you need to scan 2 shirts. After completing the scan of the first chart, click Next and continue to scan the second chart. When the scan is finished, click Next. The Fiery Calibrator will then process the scanned data. A final dialog will display the details of the new profile, including the profile name you chose at the beginning, creation date, and listing the charts and equipment used such as color space, the printer, spectrophotometer, measurement mode, and the number of patches scanned. The creation of the print mode is complete. Click Done to finish the process. You will return to Digital Factory, where the new print mode will now appear in the Print Mode Manager list. You are now ready to print your jobs, confident that you can create accurate and repeatable color consistency.